question paper standard. So what the questions are? I think most of the problems are very much simple, you could solve, such as that the first problem, it has been given that is integration 0 to infinity e to the power minus x square x to the power 4 dx. In this case, of course, to match this with your gamma function, we have to consider let x square equals to t, and then after the correspondingly you change the integral and you will get the value. I'm not evaluating this integration, I think we could do this one. You have integration 0 to 1 integration x to 1 cos y square cos of y square dy dx. Now for this type of integration, I think we have solved one. Okay, so what is the range? If you are going for that range, it comes to your y equals to x, that is the line passes through this one.
बोलो क्या बोल रहा हूँ?
Y equals to x and y equals to 1. So that is this.
Go to xy को देखते हैं क्या है? पहली बार देख रहे हैं go to xy में.
So y equals to 1 and then x equals to 0 to x equals to 1.
पूरा थोड़ा ही पढ़ लिए हैं. Go to xy function places the cursor at the desired location.
Saurabh Raj, mute yourself. Okay, now we have that morning. We have y equals to x to y equals to 1. So that is, we have this strip. Then after strip, now we are taking the range from your x equals to 0 to 1. So now this one we could not be integrate. So because the integrand is given in that form, so we need to be change the order. And I think you know that you could do this one. That is y equals to x. So we are taking this from x equals to 0 to x equals to y and ranging from y equals to 0 to 1. So therefore we can get this integration can also be right y equals to 0 to 1, where integration x equals to 0 to x equals to y. Then you have cos of y square dx dy. Then I think you can integrate this integration. It's a simple integration and we can use it to evaluate that integration without any formulas. Come to the third one, and the evaluating this integration, it will come to your integration y equals to 0 to 1. Then for this one you have that for with respect to dx, that you have x cos y square, you have that x has its range from 0 to y dy. Then it comes to 0 to 1, you have that this is your y, so we can take half cos y square d of y square. It comes to your half, that is sine y square. Limit is 0 to 1. This comes to sine 1 is equal to, that is 1 by 2 sine 1. That will be the answer. If we come to your third problem, integration minus 2 to integration minus under root 4 minus x square to 4 minus x square under root of x square plus y square to 2 that you have dz, dy and dx. So now we have that to integrate with respect to z. So that comes to your integration minus 2 to 2
बंद कर दे हाँ वही चालू
under root 4 minus x square to 4 minus x square. That comes to your z. Z has its ranging from under root x square plus y square, that is 2 dy dx. That we can replace that is your 2 minus under root of x square plus y square dy dx. Now for this one we are considering that the polar coordinate, that is x equals to r cos theta, y equals to r sin theta, so therefore x square plus y square, it comes to r square. This implies r equals to under root of x square plus y square. Now if you see the range, that is your from negative part to the positive part, if you consider that y equals to, then x square plus y square equals to 4. So this portion is considered to be a circle. The range of this is given from minus 2 to 2. So therefore we can consider that r equals to this one. Then for your dx dr, that is your dy dx, we have to take the help of the Jacobian, that is the way transforming the field from xy to your r theta coordinate, and the Jacobian of this transformation, as you know, that is your r, so that is r of dr d theta. D theta, since we are considering the whole circle, so r will ranging from your, for r has its range has to be your 0 to 2, and theta is ranging from 0 to pi by 2 pi, 0 to 2. So therefore the integration comes to integration 0 to 2, integration 0 to 2 pi, that is 2 minus under root x square plus y square, that is your r, 2 minus r, and then after r dr d theta, that is equal to, if you are integrating this one later on 0 to 2, that you have theta for you have 2 pi, and then you have 2r minus r square dr, that you have to integrate. It comes to 2 pi, then you have r square minus r cube by 3 from 0 to 2, so that comes to 2 pi. You have 2, that is 4 minus 8 by 3, 4 minus 8 by 3, so that comes to your 12 minus 8, that is 4 by 3. So 4 by 3 into 2, that is 8 pi by 3. 8 pi by 3. The answer. Okay. To the next one. That is for your sine theta. Is that expression? Okay. Number 4. You have a function fx. You have a function fx equals to sine theta, and the question is that using mean value theorem, it can be proven that for x greater than 0, we are considering here sine x. Your sine x, fx equals to sine x for x greater than 0. That's the idea, it is given here. So since the expression consists of your x square, so here we consider that is up to your second order derivative. So therefore you have fx, f dash x, that comes to your cos theta, cos x, f double dash x, it comes to your minus sine x. It comes to your minus sine x. Okay. Now from the mean value theorem, we can have for the second order derivative, if you are writing here, that is comes to your f of x equals to f of, in between the interval 0 and x, we can have 0 plus x f dashed 0 plus x square 2 factorial f double dashed. We are considering here the point between 0 and x to be theta x. Now f of 0 is your 0 by sine 0. Cos of 0, if you are considering that, is your 1. So that is equal to 0 plus x. This comes to your plus minus x square by 2 sine x, or sine theta x. Now for any values of your x is positive, so for those values of x, sine theta x is always mod value is less than 1, so we can have that of your mod of sine theta x is your less than equals to 1. So therefore minus 1 is less than your sine theta x. Less than equals to. So here from we can say that if you consider that minus, then we can have this, we could be put it that minus 1 sine x could have its greater than your x minus x squared by 2. Okay. Then we can be established. We can have the 5.
Sir, when do we get the results, sir? Results of this exam. Marks.
Marks has not been disclosed to you?
No, sir.
It is okay, so I think it will very soon be disclosed. It's not known to me.
Okay, sir.
Because it is auto generated, it will be only few of the expressions, means few of the answer script needs to be reviewed, then after it will be generated.
Okay, sir.
You have the function that f of x equals to 1 plus x all to the power m for m belongs to your R. That the continuous derivative of every order of values of n such that 1 plus n is greater than 0, then the Cauchy's remainder after n terms. So okay, so after n terms means we have to take the differentiation since we are considering the expansion, you're starting from fx equals to f0 plus f dash 0, it goes on. So n terms will completed your at n minus 1th derivative. So for that we must have f n minus 1 dashed x, it comes to that you have m minus 1 m minus 2, it goes on. So for first one we have that m, second one we have m and m minus 1. So n minus 1 times we have m minus n plus 1. This one x to the power, you have minus 1, so you will have one more less. That is x to the power m minus n minus 2. I think we have to take here the bracket, or we can take this one. Is it? So when we change this bar. So confused. So let's say find out that once 1 or 2, that is f of x equals to your m1 plus x to the power m minus 1. So f double dash x comes to your m minus 1 x to the power m minus 2. So for double dash we have the 2, so n minus 1 dash we must have that n minus 1. So 1, and therefore here we have minus 1, and this would be less than 1, and that is m minus n. M minus n. Is this minus n? It is round. So 1 minus total minus 2. Is 2 m minus n. Second order we have m into m minus 1 is to m minus 2. So in that order, we should have m minus 1 m minus 2 plus n. What that should be? M minus n minus 1. Getting confused, so I'm writing once more. Triple dash x is your m minus 1 m minus 2 x to the power n minus 3. So that should be n minus 1. That should be so that should be m minus n. Yeah, that's right. So that is your derivative. Now we have to find out the Cauchy's remainder. So Cauchy's remainder has its form. Let's write the Cauchy's remainder. Cauchy's remainder is Rn is equal to your 1 minus theta whole to the power n minus 1 into divided by your h, that is your h, then n minus 1 factorial, it's n factorial, minus 1 factorial, it's n factorial, and if n dashed theta x, you can say that is in terms of theta h. So we have found that if n minus 1, that will be the last term, we need to find out if n dashed. So if n dashed x equals to m minus 1 goes on m minus n and m minus n minus 1 n plus 1, then x to the power m minus n, it reduces, so plus 2. So then after we are just changing this theta x by your theta, so therefore you have this is minus theta whole to the power n minus 1 by n factorial. This comes to your m minus 1, it goes on up to m plus n plus 1, m minus n plus 1, and that is your theta x to the power, that is theta x to the power, sorry, oh sorry, this would be 1 plus theta x, this would be 1 plus theta x, 1 plus theta x, there is no change in that. Power of this, so that x will be replaced by theta x, that is 1
Sir,
plus.
here factorial will be n minus 1.
Yes, sir. N minus 1 factorial.
No, why that n minus 1 factorial? We are taking that the remainder after your n terms. So after n
Yes, sir.
terms,
N minus 1 factorial in notes.
It will be
oh, but why that n minus 1 factorial? We are taking that the remainder after your n terms. So if you start from your 0, that is f of 0 to your f n minus 1 dashed 0, so the next term will be your f to the power n dashed 0 by n factorial along with the sum term in case of your Cauchy. So that comes to your n factorial, so whole to the power your m minus n plus 2. Now this
Sir,
has
in
been
Cauchy is it the denominator is n minus 1 factorial for n term. In Lagrange's it's n factorial.
oh in case of
Yes.
Cauchy.
yes, sir.
So I'm writing n minus 1 factorial is this. Now I think you can rearrange this one and you will get the answer. That is your 2 1, then something 1 minus theta whole to the power n minus 1 divided by 1 plus theta x whole to the power n minus 1, and then you have another term that is 1 plus theta x whole to the power n minus 1 divided by n minus 1 factor. That will be the answer. Next, there are few problems which are very much more easier to you. That is problem number 6. is your you have to find the lies between which two value. Mainly we consider in that case you have to find out the approximation of 101. So we consider the function f of x. In such case, that is under root of x over the interval your 100 and 101. So therefore f dash c equals to f b minus f a divided by b minus a. So f dash c is equal to your f of 101 minus f 100 divided by 1. This comes to your under root of 101 minus 10. How much is your f dash c? That is 1 by 2 root c. 2 root c. So therefore you have that under root of 101, it comes to 10 plus 1 by 2 root c. Now c is a number which is your less than less than 101, more than 100. So therefore root c, 1 by root c is your less than 10. So is your 1 by root 100 is 1 by 10. 1 by root c is your 1 by 10. So we can replace that value. That is your less than 10 plus 1 by 2 into 10, which comes to 10 plus, that is 20, that is 0.05. So 10.05. So we can consider that the approximate value of this one is lying between that must be more than 10. So 10 and 10.05. So this is your greater than, of course, 10 is. Next one. Gamma 7 by 2. From 7. So gamma 7 by 2, we have to break it into the fraction. That fractional part gives you that 5 by 2, gamma 5 by 2. So gamma 5 by 2 now comes to 3 by 2, gamma 3 by 2. 3 by 2 gives you half gamma half gamma half gives you root pi. Then you can find it. 8. 0 to infinity. Root x. That is the integration. This we can write down in the form of your integration 0 to infinity, I think x to the power minus half dx, x to the power minus half dx, then 1 plus x. Okay, that we could be write down in the form of your beta function, such as integration 0 to infinity, then x to the power that n minus 1 or m minus 1. So that can be written as minus 1. So 3 by 2, half minus 1. You can write half minus 1. That gives you minus half divided by 1 plus x. So that means we can write down 1 plus x to the power. If m is your half and we have to bring it that 1, so half plus half plus half dx. That comes to your beta function. beta half and half, which is your gamma half, gamma half here by gamma 1. That comes to your gamma half and half is your root pi, that is pi is the answer. Comes to
Sir, how does beta half?
Beta function ranges from 0 to 1.
Yes,
So
sir.
0 to
0 to 1 limit must
0
be
to 1,
1
sir.
plus.
It is diverging. This cannot be solved, this integral. I have performed the mu test, and from mu test it was showing it was diverging.
Sir, we can
mu.
only substitute
Yes, sir.
No, no,
I
that
also
is the
performed the
form
new
x to the
test.
power n minus 1 by 1 plus x to the power m plus n. That is why it is similar to gamma function.
But if you consider that mu test also, then the
It is
factor you are
convergent.
if you are taking that x to the power 3 by 2, so that 3 by 2 if you multiply you will get a finite value, and 3 by 2 is your more than 1, is it? And there is a property for your beta function, something like that, I think beta mn integration 0 to infinity x to the power m minus 1 by 1 plus x to the power m plus n dx. I think so. There is a property, something of that expression, and that can be obtained by
Yes, sir.
substituting
Okay, sir.
your something that substitution is something x equals to 1 by 1 plus y, something like that. Okay. If you take this substitution, you will get this expression, something. Okay. We have the last one, and last one I think is your not exist, that is that has been said it is your false, because if you are getting that, is it possible that both the iterated integrals of a polynomial function on this are exist but the double integral may not exist? It will not be true, it must be false, because if both the iterated integrals are your exist, then it must be your double integral be exist, because we are taking ultimately the Riemann sum, and on that Riemann sum if your iterated integrals are exist, then we must get that the solution of that. Okay.
Sir, one doubt in this question only, question 8.
Mhm.
Sir, for the mu test, if we do it for the diverging case, for diverging it is mu less than equal to 1. So if I put mu is equals to half, meaning root over x, so it will come a finite value. So that finite value gives us the hint that it is diverging, because sir only wrote that fx is diverging if that limit equal to lambda, not it should not be equal to 0, but it can have any value between minus infinity to plus infinity. So
But
sir, two, yes sir, that is the confusion why it is not diverging then.
no, I'm saying that if you are taking that the function x to the power mu, that means your root x to the power half f of x, is it, as x tends to infinity. So x to the power half, this comes to limit x tends to infinity, you have 1 by 1 plus x. So as x tends to infinity, this comes to your 0. So for that 0 we could not conclude something like that. Okay, if it be a non-zero some finite value, that means some value which is your suppose c which is not equals to 0, then you can conclude something like that. But if you consider that limit as x tends to infinity, x to the power 3 by 2, 1 by
Sir?
1 plus x to the
Sir,
power.
so in the upper expression,
Sir,
what
question
is
number
the
9.
value of mu that you have taken?
Sir, in this question, can we apply this one directly? Because for the type from 0 to infinity, the function should be continuous at 0 also. But in this case, we have a root x in the denominator. So won't we have to split it into two integrals and then use the second type mu test? Where
No, they
we
have
get,
said you to, I think they have said you to evaluate this integration, not to, where is
no,
that
sir, you were
problem?
checking for divergence and convergence, and that's why I was saying that.
Mm-hmm.
For
So
that, we
if
have to split into two. Otherwise, we can't directly apply the 0 to infinity because the function should be continuous at 0 also, according to that definition.
the function is you're not continuous at 0, so therefore you can exclude that point 0.
That's why,
Okay.
sir, we have to use the second one, na, because
So
in
second
beta
second
function
mu
also
test
we
one.
have to submit while we were proving the convergence of beta function, we were splitting into two because it wasn't continuous at one point. So that's why we had to use the second mu test because it said that if it's continuous in the interval of a plus c to b, where c is some number between a and b. That's why we have to use the second one here. And for the first one, it explicitly said that it should be continuous from A to B, both close bracket. Well, from
लेकिन अगर हम जीरो पर टेस्ट भी करेंगे म्यू टेस्ट तो एक्स की पावर हाफ लेने पर वो कन्वर्जेंस आ जाएगा, कन्वर्जेंट हो जाएगा.
still, sir, but we have to abide by the definition.
एग्जिस्टेंस थ्योरम भी तो लग सकती है, एग्जिस्ट तो करेगा ही.
That is actually from the beta function we can be solve this one directly, and need to be taste of convergency. I
Sir,
didn't.
actually, this property wasn't discussed, so I couldn't figure it out, like how to integrate it.
That I didn't know.
Sir, can you please repeat the last question, question number 9, sir?
The question number 9 says that is it possible that both the iterated integrals of a polynomial function on your closed interval, it is given ab cross ct, exist? Both the iterated integral exist, but the double integral may not exist. Is it your true or false? Okay, this is your false.
Sir, like Satya sir said that fx be an integral function from x greater than equal to a, then then
Fx.
capital F equal
No,
to
but both the
integration a to infinity.
iterated integrals may not be equal.
Sir, the last one would be true, sir. Sir, there is an example which is
Yes,
given
sir.
for x
LKT
minus
sir
n
told
plus
us
one.
that it will be true.
Yes, sir. LKT sir told you that.
It would be true, sir, the last one.
Both the iterated integrals are exist, but the double
Yes,
integral
sir.
may not exist.
So but
Yes,
it
sir.
is told that it's a polynomial.
Yes,
Then
it's a
Yes, sir.
polynomials
polynomial.
Polynomial
always
means
exist.
false.
Sir, in our lecture notes, it is also mentioned the same thing, sir. F of x comma y, sir.
Yes, sir. In our
No,
lecture,
f of
it is
x
also
comma y, f of x comma y is not always or every time to be a polynomial function. Okay, f of x comma y be any function, but polynomial function is a function which is actually your continuous everywhere. So therefore, being a function is your continuous, and we know that by your Riemann sum, you must have that the double integral is your exist.
sir. Y can be a polynomial, na?
Can be a polynomial. If it be a polynomial, then it must be satisfied, and that is the case in this. And if it not be, then we need to be means under the question, bring it under the question.
So, but when both the iterated integrals have different value, then multiple integrals should not exist.
That is not being said here. They have said that they are exist. Both of them are exist, and
But they can't
they
have
are
the same value, sir.
Yes,
that
sir.
has not
Both of
been
them exist, but
specified.
not the same value. That's what I was telling.
But that has not been said here that they are not being equal. Okay, just only being said that they exist, but the double integration may not exist.
सर ये स्टेटमेंट तो ट्रू होनी चाहिए सर.
This may be
Yes,
true,
sir.
sir.
Sir, it has only mentioned that it exists, sir, but it has not mentioned whether it is equal or unequal. So how come we will
Yes,
understand
sir.
that it is equal or
Yes,
unequal?
sir.
Yes,
Yes,
one
sir.
question.
Okay, then you just talk to Soto sir. Soto sir can give you the clarification on that one. He can also only be that clarification. Okay, so that's all for today.
Thank you, sir.
Thank you, sir.
You wait, I just
Sir?
take it. Yes.
Thank you, sir.
Sir,
Thank you,
can
sir.
you revert the limit?
Thank you, sir.
Sir,
Thank you, sir.
sir, sir,
Yes.
sir, can you divide the limit? I mean, limit a to 0 to plus